In this question, we're asked to get the frequency and energy of a photon given a wavelength of 530 nanometers. Okay, one thing to remember is that c, which is the speed of light, is equal to lambda times nu. Lambda represents the wavelength, nu represents the frequency. So if we rearrange this formula, nu, which is equal to the frequency, is equal to the speed of light divided by the wavelength. The speed of light is a constant. That's going to be 3 times 10 to the 8th meters per second in a vacuum. The wavelength is 530 nanometers. But we have to be careful here to cancel out our units. We have meters on top and nanometers on the bottom. So we should use a conversion factor. We'd like to get rid of nanometers on the bottom and get to meters. So our conversion factor is 1 times 10 to the 9th nanometers are in 1 meter. Now notice what this does to our units. Meters cancel out, nanometers cancel out, and we're left with per second. That's good. That's the units we want for frequency. So when we're done, our frequency is going to be equal to 5.66 times 10 to the 14th, and that's in units of cycles per second. That's the answer to the first question. The second question asks us to get the energy. Energy is equal to h times nu. H is Planck's constant, and that is 6.626 times 10 to the minus 34 joule seconds. And our frequency we already have from above, that's 5.66 times 10 to the 14th per second. Once again, let's look at our units. Seconds and per seconds cancel out, so we're left with units of joules, which is perfectly good for energy. The value that we get when we put it into our calculator is that energy is equal to 3.75 times 10 to the minus 19th joules, and that's for 1 photon. Now, our last question asks us, what is the energy in kilojoules for a mole of photons? So now we need to work on that. Okay, from the previous slide, we have 3.75 times 10 to the minus 19th joules per photon. And that's for 1 photon. Okay, well, let's remember that there are 6.02 times 10 to the 23rd photons in 1 mole. Photon. Okay, so we need to take our answer here and convert the units from photon to moles of photon. This gives us a value of 2.26 times 10 to the 5th joules per mole photon. And the question asks us for the answer in kilojoules, so let's remember that there are 1,000 joules in 1 kilojoule. So when we finish multiplying this out, our answer is 2.26 times 10 to the 2nd kilojoules per mole photon. And that's the answer.